So let me take you to Himalayas. So I was living next to this woman's home. So I took a picture of her, picture of her cooking, and I tried to talk to her about how this impacts global climate. And she didn't believe a word of what I said, of course. So I took her outside, and she was shocked. So that's the smoke coming out. I was just living on the hut on this side, okay? But so there's just a local thing. I fortunately had the satellite image, okay? So you can see a river of pollution covering over most of India. Remember, that's the Indo-Gangetic Plains. There are about 700 million living along that, from Pakistan all the way across India to Bhutan. Its effects on the local climate, regional climate, as well as health has been documented through over tens, if not hundreds of papers. Just inhalation of smoke alone causes over 500,000 deaths. And the smoke and the pollutant in the smoke destroys over millions of tons of crops. We have shown that the soot deposits on the glaciers, not only our group, Chinese glaciologists, Nepalese have shown the black carbon settles on the Himalayas and contributes to melting. It disrupts the monsoon because it intersects with sunlight, so on and so forth. So, and I was just at the World Health Organization 2 weeks ago, and they released a major study which sort of upped even the stakes. They said the household air pollution from solid fuels accounted for 3.5 million deaths worldwide, much more than any other disease in certain parts of the world. And of course, this escapes outside, combines with the outdoor pollution, and kills another 3 million. So it's a huge public health issue. And I'm going to talk to you about a project we started at University of California, San Diego. And the motivation for that, I teamed up with a well-known chemist, Greg Carmichael from University of Iowa, who was simulating this black carbon you see on the left-hand side using all the sources. So I asked Greg to do a simple thought experiment. Let's replace all the cook stoves, okay, with smokeless cook stoves. And the picture on the right came as a remarkable revelation to me. You can see that most of the pollution from India is wiped out. Okay? So then started a quest for how easy or how complicated it is to replace this mud stove. So this project Surya was initiated here. Now we have major partnership from numerous institutions, but the primary partner is a well-known NGO from India, on the Energy Resource Institute. So we started it as a scientific problem. So the cook stove issue has been studied by over hundreds of NGOs over the last 10, 20, 30 years. It's a well-known problem. And people have tried to solve it and have failed. So they were very skeptical when they said some physical scientist from university is going to look at this issue. Anyway, our issue first was to demonstrate how much pollution was really coming out and how much of the outdoor pollution was coming from indoors. So we started a series of developed protocols, started from the mud stove, baseline monitoring, testing them. Then we developed and customized the stoves to the local culture, disseminated the stoves, and then monitored it post-dissemination. And the key thing was we wanted to collect data at every home. Remember, I told you there are 650 million, assuming 5 per household, but 150 million homes. So we had to rely on cell phones to document it. Okay, and you can see the cell phone. One thing developing economies have exceeded the developed economies is using the cell phones, and you can see how it has increased. So we use the cell phone as a platform to make measurements of soot. Okay, we just take 30 seconds to explain this. the left-hand side, you see a small pump, battery-operated pump. It draws air and stains a filter, and the filter is put on a template, and you take a cell phone picture, and then the color of the filter is reduced to soot concentrations using some calibrated instruments. And then we developed, we tested various technologies. You see on the right-hand side the so-called advanced stove we have settled on. The key thing is it still uses biomass. Okay? The reason that's critical is that it's free. At $2 a day, they can't afford to buy anything else. Okay, so the fuel is free, so we were restricted to that. And we show there the emissions of black carbon or soot at both the whole house level and the breathing level. And if you follow the blue one, the traditional mud stove, the natural draft, there are various stoves others have developed. We are focusing on the so-called forced draft. You see that it brings the black carbon concentration by almost 70%. And if it's done properly, the reduction is as much as 80%. Okay? And I will later describe what's in this improved cook stoves. But basically, it has a gas chamber, contains the heat and the hot gases, which are ignited at the top, and there is a fan. After all, why do you produce smoke or black carbon? Not enough oxygen, air. So this fan gives a steady supply of air. So the advanced biomass stuff reduces the fuel consumption. We have documented that by as much as a factor of 2. Reduces PM, those are the particulate emissions. Reduces black carbon emissions, reduce carbon monoxide. Why is all this such a big deal? How does this cut into sustainability issue and climate change? So I was doing this project for 3 years. Sitting in my beautiful office at Scripps, I decided I have to go spend time in the village. Okay? So I spent 2 months in villages in India. I started from the south, where I come from, and worked my way up across India and ended up in the Himalayas. I showed you the picture from the Himalayas, right? So let me just walk you through. So that's the entrance to my village. Okay? That guy could have been me. That's where I spent a lot of my summers there. Okay? My grandfather stayed in about a city 5 kilometers from there, and we used to go to the village every day, sorry. So the green pasture you see was my grandfather's village. So I found out by sheer luck, this guy was the grandson of the farmer who took care of my grandfather's village. So we walked there to interview about 25 women. And they had all gathered that day to sort of make a passage for this canal. And just to give you a background on what this region was, this area is well known. Within a 20-kilometer radius, there are 2,000 temples. Just sort of a miracle region there. And amidst all this chaos are these beautiful temples. And this one was built 530 AD. Okay? And so this region is well known. And right now, the region that is well known was it used to be called breadbasket of South India. Now, because the rivers are running dry, it's become a drought-prone region. And the cook stoves cuts into this. That's why I'm slowly building up that story. So I showed you the beauty. Let me take you to the inside the home. Okay, that's the home next to my grandmother's farmer home. That's all the lighting you have. Okay? And she has to cook in that. And this is nighttime. The reason is, I've seen people here sitting in Berkeley and MIT over-engineer these cook stoves, improving the efficiency from 21.5 they rejected to 22.5. Here we are talking about 0. Okay? So that's what we have lost sight of. And one of the reasons why these cook stove projects fail. And that's nighttime, okay? So this is daytime, okay? And by the time I went to breakfast, which was around 7:30 in the morning, I was lazy, because, see, the villages have no heating. That's an important part of my story. I'm going to come to that. So just lying in this cold bed the whole night, okay? And she had already got up at 6 o'clock. She'd been cooking for an hour and a half. Had a beautiful breakfast ready for us. What does this all mean? You saw all the flames. So I finished breakfast, as walking back, and you can see smoke filled. Okay? So that's how we saw in the satellite images. So that's only one source. The other one, I wanted, let me just say seriously, yeah. See, this was just transitioning from dry season, so they were preparing the soil, burning all the leftover stuff. This plume, I tracked this with the car. Just these two spread across 80 kilometers. Okay, and along the way, numerous other plumes. And there is a former postdoc of mine. She's a professor at IRPS, Jen Burney. She has documented the direct effect of these short-lived climate pollutants has knocked off agriculture production in Uttar Pradesh by 30%. Okay, I'll tell you about what that 30% means.